Hi guys, this is Shivardi. In this session, we are going to look at how HashMap works internally. In this session, I am going to explain in detail about how HashMap works when we are trying to put an element in the HashMap as well as while retrieving the elements, and what are the different collections we are going to use to use it by the HashMap to store these elements internally. So this is going to be the one of the most important interview questions. So I am going to explain this concept in detail. First, what I am doing is I am created a one small program to explain that how HashMap is going to be created or used in the Java application. So in this HashMap, what it is going to have the key and value pair relationship it is going to maintain. First, let us see what is meant by HashMap. HashMap is going to maintain the key and value pair as a relationship. And what is the main difference between a hash map and hash table? In the case of hash table, it does not allow any null as a keys, and also it is going to be a thread safe. In the case of hash map, it allows the single null as a key, and also it is a not thread safe. So that is the main difference between a hash map and the hash table. Remaining concepts is going to be exactly same. Now, whenever you are trying to add an element to the hash map, so what happens we are going to see. But before we go here, let us see the few concepts we need to know about how hash map uses internally. The first one is hash map is going to used based on the hashing principle. Hashing principle. So this is going to be whenever you are trying to store an element or getting an element from the hash map, the hashing principle is plays a vital role in this. And then whatever the key and value pair we are going to store in the map, it will be in the form of map dot entry. That is string comma string. That is key and value pair. It is going to be maintained. That means each entry whatever you are going to add, that will be maintained in the form of map dot entry. And also it will plays a vital role of hash code, because hash code is the one which is going to identify which bucket it needs to be placed, and also while retrieving the object from the hash map also, this hash code is going to used very a lot while you are working with the hash map. And also we have another concept called the equals method. Equals method also will plays a vital role, because whenever two or more keys having the same hash code, then the equals method is going to rescue to identify which key it needs to be fetch while getting the value at the same time while saving the while storing into the hash map. We are going to see in detail about the this concept, but basically we are going to use these concepts while we are trying to store an element in the hash map, while at the same time while getting the element from the hash map. Now let us go ahead and see this here. So what I am doing here is hashmap.put. It is going to store an element to the hash map. How it is going to store? We are going to see the source code of the hash map, and I am going to explain that concept. Here what we are doing is we are going to first put the value of key and value. For example, as hash map can allow the only one key, then what happens is if the key is null, then it is going to store in the index of 0. That means what happens is, before I explain here, the hash map is going to be maintained in the form of the buckets. That means whenever you define a hash map by internally, it has its own capacity. That means if you don't specify any, that means let me go through here. So here, this is the empty construct is the one form of the constructor, but another way you can define using the initial capacity. If you don't define the initial capacity, the default size is going to be the 16. That means when you don't define any initial capacity, then what happens is the bucket size is going to be the 16. That means it is going to maintain a bucket of 0, 1 and so on. It is going to maintain the 15. This is the if you don't define anything, it is going to be the maintains the initial of 16 buckets, that is going to start from the 0 to 15. Now what happens is every time when you when every time when you put an key value pair, then it is going to be identify particular bucket, and it is going to be place the value, the particular key and value pair in the particular corresponding bucket. Now in this case, what happens is when you say key is a key value as a null, then it is going to be store the value key and value pair in the index 0. If you see here, this is going to be the how it is going to add. If it is null, then it is going to be added to the 0th position. So, and also in the case of hash map, when we are trying to store an element, how it is going to store is going to be hash code, key, value, and what is the bucket position. So it is going to take the 4 parameters. I am going to go to the add entry. Add entry is basically going to take the hash code, what is the hash for that one, and what is the key, and what is the value, and what is the bucket index. So in the case of null, when you pass the key as a null, then it is going to be stored in the initial, that is index 0th position. It is going to be storing as a map dot entry, that is key and value. Okay, so whenever you say key as a null, then it is going to always going to be stored in the first position, that is the index 0th position. It is going to be stored. Okay, now let us consider you are not no, you are not passing a null as a key, so it is going to be always will be the some value for the key you are passing. In that case, what happens is I'm go back to the put method implementation. If you see, for example, if it is not null, then what we are going to do is we are going to calculate the hash for this. Then how we are going to calculate the hash is, it is a some random value. It is going to be uniquely gives you the hash for the particular key and particular key. And also we are doing the two type of the hashing. First one on top of key dot hash code, it is basically object. Every object is going to be implement the hash code, the default implementation of the key. It will return the some hash code. On top of again we are doing the hashing. This is because the we are always make sure that whatever the hash code it is going to be written for the particular key, it should be unique across the buckets, so that the while fetching or the retrieving the element from the hash map, it is going to be higher performance. That is the reason we are doing the two level of hashing. One is on the key we are calculating the hash code, which is going to be the same implementation of the object how you are going to do it. And second one is again we are doing the on top of whatever the hash code it returns, again we are going to calculate the hash based on the this logic whatever it is going to be implemented. This is basically to make sure that whatever the hash we are going to calculate will have the distinct value for the each key whatever we are going to place in the hash map, so that while retrieving the value, the performance of the getting the value, getting the particular key corresponding value or the corresponding object from the hash map is going to be having the better performance. And now let us consider once again. I am going to the put method of the implementation. Okay, put. So now what it is going to do, first it is going to calculate the hash, and hash we are going to pass this value to the index for. Index for basically returns you the what is the index of the bucket. So you are going to take the hash code, and what is the length is nothing but the capacity of the capacity or the table length. Table length is nothing but the capacity. So it is going to identify which index it is. Now what we are going to do is, once it identifies the particular index, then it can have the two. Again there will be a two scenario. One scenario is going to be if you pass for the hash map like with the same key again, then hash map what it is going to do is it is going to override the previous key or value with the new value. For example, here I am adding the key 1. Again, I am placing the key 1 and value 2. In this scenario, what it is going to do is it is going to override this value with the this value. That means, sorry. So previously, whatever the value is going to be replaced by the latest value, whatever you are going to add. So that is the reason, if you see here in the case of object, if it is already available, then it is going to be override the new value is going to be overridden. Otherwise, it is going to be added to the new entry. So new entry, how it is going to be hash value and key value, and what is the bucket index, whatever we are going to pass here, it is coming here and it is going to be identify that value. And one more thing is, for example, you are adding with the key and value. In the case of adding also, it will make sure that first it is going to create a hash value, and then if two keys are going to have the same hash value, then it is going to apply the equals of the operator on top of these two keys, and it is going to check that whether two keys are the same or not. If both the two keys are having two key equals method having equal, then also it is going to be overriding the first value with the latest value is going to be override by the old value. That is how the put method is going to be works. So it is very simple. First it will identify whether it is a null or not. If it is null, then it is going to be place the new value in the index of 0. If not, then again two scenarios it is going to be handled. One is whether whatever the key is already existing in the hash map or not. If it is already existing, then it is going to be the new value should be overrides the old value. If not, then it is going to add it to the bucket by identifying with the hash what is the hash code and key value by identifying the bucket index. So this is how it is going to be added to the bucket. For example, now you are keep on adding the entries to here and it has reached the maximum threshold. For example, you are adding like a element of your initial hash map has the 16 capacity. Now you are trying to add the seventh element. Then ideally what needs to do is it needs to resize the hash map. So that is what here it is going to do. Whenever happens, it is going to reaches the maximum threshold of the table size or the size, then it is going to double the size of the hash map. So this is how it is going to be calculated. So based on that, it will hash map by make sure that based on the load factor and the initial capacity, the resizing is going to be works. I am going to explain that concept in detail. But whenever it is going trying to insert an element, even the first use cases, whether it is 0, then it is a key is a null, then it will be added to the 0th position. If not, first check whether the key is already available in the hash map or not. If it is available, then it needs to be overridden. If it is not available, then it is going to add a new insert, and while inserting it will check whether the newly added hash map having a capable to insert the newly adding entry in the hash map. If not, it is going to resize the hash map. That is how it is going to work for the put. Now in the case of get, what happens? Get is also, it is almost similar to the put, but in the case of what is the methods it is followed, it is the same. For example, whenever you are trying to get an key, then first it will check whether it is a null or not. If it is null, that means I'm going to see the get implementation. So first it will check whether it is a null or not. If it is null, then it is going to identify the 0th index and 0th index, and then it is trying to get the whatever the value it is placed in the 0th index of the bucket. For example, in this case, it is going to be 0, and that value it is going to be written. Okay, and next one is if it is not 0, then what happens is it is going to calculate the hash code of the whatever the key we are going to pass, and by using this hash code, again it is going to identify the what is the index for that particular hash code in the hash map, and with that it is trying to get the value for that. Okay, and one more thing here is, here in there is a chance that two or more in keys will have the same hash code. In that case, what happens is first it is trying to identify the what is the index for that. For example, if it's a 0th index, and then here two entries, whenever any two keys having the same hash code, then with the same bucket it is going to be maintain the linked list. So now let us consider for the 0th indentation, key 1 and key 2 are having the same hash code, then it is going to be maintained in the form of linked list. And now what happens is for the two keys, the bucket is going to be 0. Then what happens is, and hash code is also same. Then what now the hash map will do is, it is going to apply the equals method and try to compare whether this key value and whatever the keys is same or not. If it is same, then it is going to return that particular element, or the particular key and value pair it is going to be returns. So that is the reason the get operation is always having the same process how we are trying to use for the put. Okay, so that is how it is going to be get the value from the hash map. And now, what is the performance of the get and put for the hash map? See, the as per the Java docs, what the norm is going to be, as long as if you are trying to disperse the keys in a proper way of the buckets, then always put and get is always going to be order of one. For example, if you are not, if your hash algorithm is not so great or the not simple, or it is trying to get the more than one key have getting the same hash code, then what happens is, instead of putting the each key value in the one bucket, it is going to be maintains a single bucket with the multiple key value pairs. Then the performance of the application is going to be degraded. Hence we need to make sure that whenever you are calculating the hash code, it always make sure that it needs to be created a distinct hash code for the each entry you are putting into the hash map. As long as you are make sure that you are putting a each a distinct hash code for the each entry you are placing in the hash map, then the performance of the hash map for the retrieve or the put is going to be order of 1. But is it is possible that, and it is also impact the performance of the hash map is also it also depends upon the two factors. One is load factor, and second one is the initial capacity or the initial capacity. So these are the two parameters which is going to impact the performance of the application of the or the hash map. So what is the load factor? Load factor is always recommended that 0.75 is the trade which is going to have the high optimization performance for the hash map, and initial capacity default it is going to be 16. And what happens is, it is 2 to the power of 4, and every time once it reaches the maximum size of the hash map, then it is going to be again it is going to be increased to 2 for 5. That means it is almost equivalent to, it is almost is going to be double the size each time when it reaches the maximum size of the hash map. And what is the what is the load factor? Load factor is going to be tells the hash map when it needs to be resized. The hash map rehashing should happen, when rehashing should happen. For example, you are adding an initial capacity of the 16, right? So now after how much elements you are adding to the hash map should resize the hash mapping, so that again the hash map size is going to be more to accommodate the newly created elements, and also it is going to reduce the collision. Collision is nothing but two or more keys will have the same hash code, so that what happens is, in as the collisions are going to be more, then to get the to retrieve particular key from the hash map is going to be take the more time. So ideally the logic is going to be like that. So initial capacity star load factor, load load factor. For example, in initially it is going to be 16 and star dot 75 star dot 75. So whatever the value it is going to be around, it will come as a 12. And once the 12th element is added to the hash map, then the rehash mapping is going to happen. And also it is going to be make sure that the size of the array is going to be 2 to the power of 5. Okay, so this is how it is going to works. And as if we see, the performance of the application is going to be degraded as it is number of the collisions are going to be more. Hence, what happens is in the case of Java 1.8, it has come up with the concept of the balanced trees instead of the linked list. Because as long as if it is a lower number of the entries it is going into the bucket, then is fine to maintain in the form of the linked list. But as the number of the collisions are or the data is going to be huge and hence, then what happens is the collisions are going to be more and it is going to be impact the performance of the hash map while you are trying to get the element. Hence, in the Java 1.8 onwards, it is going to use the balanced trees where it is going to improve the performance of the application when you have the more collisions. So hope you are clear with the hash map, how it is going to works internally. And if you have any questions, please comment on my YouTube video and please do subscribe to my YouTube channel to get more technical videos. Thanks for watching.